All right, guys, so we've got a horse trailer door here, and they pulled the pins and brought me the whole door, which is actually rather convenient because then I can take my time. I don't have to move a whole trailer around so that I can fix one piece of the trailer. So it's nice that I'm able to do this. So what we've got is pretty much what I said before, a dumpster fire. The customer has broken several of the slides on this, and they've tried to fix several things themselves, and it just is not. I don't blame them for trying to fix it themselves, but I don't think they had the appropriate equipment for aluminum. I know they didn't on this one because they built like a makeshift slide bracket out of galvanized steel. Yeah, we'll leave it at that. So we're gonna have to get this to where the gate will slide. The rancher uses this when he's loading his cows, and he says, I need to have that door to where it will slide. So I think what I'm gonna do is I'm gonna hang it with the crane so that it'll stand up, and then we'll be able to kind of move the gate, make sure that it slides, and just kind of see what we have to do to get this back in working condition. So we'll go ahead and get it rigged up. We'll stand it up. The other thing I wanted to show you guys, I was actually going to weld on another trailer, an aluminum horse trailer actually, and I was trying to fix it, and I thought, you know what, I'm going to use my spool gun on the Arc Captain. Well, I forgot that I toasted the machine that my spool gun fits. And I thought, you know what, I haven't got a spool gun for the new Miller Multimatic 220. So I thought, well, now's as good a time as any. So I went ahead and bought the spool gun. So tonight I'm going to get that hooked up on the machine. I've got to get it running where I like it. We'll do some test welds on it, and I'll show you guys how I like to set it up to run. And once we get the welder all set up, then we can come back to this and kind of figure out what we've got to do to get this fixed. So let's go ahead, we'll rig this up, we'll get this off the table so we got some room to set up the welder, and then we'll come back and we'll get this all set up. All right, guys, so here's the one I got. It's the Spoolmate 150. And it's funny, it actually doesn't say that it works with the Multimatic 220 on the cover, on the box. Thought that maybe I screwed up and ordered the wrong one. But if you get online, it actually does say online that it works with that machine. This machine came out after the Spoolmate 150, and I don't know, I guess they haven't changed the packaging or something. But this is model number 301272. They also make a Spoolmate 100, but this one can handle a little bit more amperage, so that's the one I went with. I eventually would like to get a Millermatic 355 pulse and set it up with a push-pull gun, but those are about 10 grand, so I'm gonna have to save my money. I figured for now this should be able to get me by and should be able to do what I need to do, I hope. Unless it's something super heavy, but this should do all the way up to 1/4 inch, I believe. Looks like it comes with a spare nozzle, some tips, 030 and 035. I actually bought a spool of each, 035 and 030. We're going to use 035. I usually like to run a little bit heavier wire, especially when I'm working on trailers. If it's something that's lighter gauge material, I will run 030. Typically, I'm working on heavier gauge stuff. So I do like that this comes with a 20-foot lead on it. That's going to be nice when I'm working on trailers and things like that. That's what the gun looks like right there. So we'll go ahead and get this hooked up. You guys know the drill. You slide that in, clamp it down, and then you plug in your plug to the machine. So let's go ahead and we'll hook this up on our machine. Okay, so this process is pretty much the same with any type of MIG gun, but this one obviously doesn't have gas running through it because it's a spool gun. So it's just basically a rod. I do like to follow Jody's advice and moisten these O-rings before I slide them up in here. Just kind of helps things go in smoother, helps you not roll them over. Plug it in right here, screw that in. You can actually leave this tightened down. That should be it. So I'm going to plug this in, power it on, we'll get it all set up on the machine here. Alright guys, so this is something that seems like a lot of people kind of struggle with. So I just want to walk through this real quick. I've got my wire here. This can be kind of tricky with wire because it's so soft, but we're going to do our best here. So I'm going to slide that wire into the liner, and then I'm going to push that button down and slide it in. Just kind of, you can see, it's kind of hard to explain, but I hit the button, hit the trigger, hit this button here to open the drive rolls, and then kind of shove this in with my 2 fingers, and then it's through. Okay, and then I'll just take my spool, kind of roll that up gently, and stick it in there, and try to make sure that there's no tangles and that the liner's straight with the spool. Okay, put the cover back on. Okay, so we should be good to go there. Some guys will actually pull this apart or pull the nozzle off and pull the tip, but if I can get it to go through, usually I can feel if it's going to go through or not. If it's being stubborn, yeah, I'll pull that off. But if not, I don't waste the time. I try to just run it through there. So now let's work on our settings. All right, guys, so quick update. I think I got this all figured out. I ran a spool gun calibration on my machine. When you get one of these machines and you buy it brand new, sometimes you have to calibrate the drive rollers so that the speed is accurate. And if you go into the settings, there's a spool gun calibration, and what you do is you go into the calibration and it's all programmed in. All you do is hold the trigger and it'll spit out a length of wire. It's supposed to be 24 inches. You take your tape measure, you measure it. If it's 24 inches, you're good. If it's 23 and a half, then you go in there and you adjust the measurement so it'll do plus or minus. So the first time it was 23 and a half, so I went plus a half of an inch. I checked it again, spit out another 24 inches, measured it, and it was right on the money. There's 2 of these calibrations on there that you can do for your spool gun. I did both, and it's running a lot better. The other thing I did is I took it off auto set because the way that I like the machine to run is not quite what auto set has it on. And I tried adjusting the speed and my wire feed speed, and I don't think it lets you adjust the wire feed speed when it's in auto set. So I took it off auto set. I set it at 21.5 volts, and I'm running at like 415 on the wire feed speed. And I'll show you what I was able to come up with here. Okay, so this one right here, that was the last one I ran. I actually like the way that one ran the best, the feel. These ones were both with auto set, and you can see they look just a little bit hot to me, like almost a little bit too hot. It's kind of melting away the base metal. But this one, I like how it ran. I do set this up so that it runs like spray transfer, but I want you guys to hear how I like it to sound. It's more of a hum than a sizzle. I was always taught that if you have a lot of popping going on, it's not good. You probably need more wire feed speed. So just listen to this. It's just kind of a hum. Okay, so once I get going there, there's very little popping. There's a little bit of popping, but I think that's actually because I like the wire feed speed a little bit higher. If I were to turn the wire feed speed down a little bit, I wouldn't get any of that popping. I would just get straight hum. But the way I run it, I like to push, and I run like a whip. And so like a whip and pause motion. That's how I like to run aluminum. And I just feel like it's easier to get a good looking weld when I have my wire feed speed up a little bit faster and you're able to travel a little bit faster. So I'll go ahead and run a third pass on this, listen to the sound again, and then I'll show you what we got. Again, I'm pushing, and then I run a whip and pause. Here we go. Okay, now before I clean this, I'm going to show you guys. This is some dirty aluminum. And I do have my argon turned up to like 26, 27. They say between, I don't know, 25 and 30. Hopefully you can see that okay. There's some good cleaning action. You can see the distinguished line there between the black and the white. And then you can see the pattern that I get when I run my whip on there. That's about how I like it to look. Now granted, this is piping hot, and so it's like preheating your aluminum, so that definitely will help. I think that's where I like it set. So, you know, for this situation, obviously the thickness of your material is going to change your settings, but for what we're going to be welding on, I think this is going to be about right. I may have to turn it down just a little bit depending on what we're welding. Now that the machine's set up, we'll go over and I'll show you guys this situation we got over here. Okay, so here's the trailer door, and there's actually a bracket like this one that's missing right here. And then this is the makeshift galvanized steel bracket that the rancher used. So I think what we're going to do is we're going to take this off and we're just going to build a whole new setup for the top. And if you look, all right, so if I grab the door and I pull it up where, this is where it should be, right here. And there is some UHMW pads right here. We're just going to leave those where they are. And we're going to build a similar setup up here. There's actually a UHMW pad right here. And once we get our other bracket down here and our bracket up here, I think the way this was set up before is there was, similar to the bottom, just kind of a bracket here, here, and here. I'm thinking of doing just one solid bracket across the top. It'll have some UHMW in it. I'll take and break a piece of aluminum and I'll weld it to those 3 spots. That should fix the problem, and then we'll have to repair this one. They did bring me one of the, I think it's this bottom one, the bracket. So I'll clean that one up and weld it back on, and then hopefully that gets him back up and running. So there's also a couple cracks on this we got to repair. I'll show you guys those when we get to that, but that's kind of the situation. So first thing I want to do is pull that off and try to figure out how we want to deal with that. Goodness. I am not sure how they did this. I don't even know what to do here. It is quite a situation they have. All right, I gotta get these off. I'm thinking I might just cut them off because this has to come off. But this situation on the backside, you can't get to the backside of these bolts. So this is quite a deal. I'm gonna go ahead and get these off. If I have to force them off, I will. So I've got the door assembly up on the table here. I figure we better fix that first. So this, as you can see, it's completely broken. So I've got to fix that. So I got to go through, clean all the weld off this. I'll gouge it out just a hair. The inside of this is pretty scary looking. We'll go ahead and clean this all up, get it ready to weld. Looks like it's about 10 gauge, so I'm going to tweak my settings on my welder for that. I did pull the latch off so that I could get to it. So we've got to do this all the way around, and then there's one crack down on that corner that we'll repair. So I'm going to go ahead and do that right now. Once we get this fixed, then we can start working on the actual sliding door. So we got to get this part done first, so let's go ahead and do it. All right, guys, so I got my welder dialed in. I've got it set at 21.3 volts and 380 on the wire feed speed. Like I said, this is 10 gauge, it looks like. 1/8 inch wall, somewhere around there. So I got this corner, this crack came out into the gusset, so I gouged it out past the end of the crack. I am a little worried about deep in this corner. You can see there's still some dirt and oxidation down in there. I've tried to get it with just a wire brush. It's just hard to get in those corners. So I'm sure that corner is going to be fun. We're just going to weld this around here, and then I may add a little bit right here just for reinforcement. There's also a spot right here that we're going to have to build up because it was almost wore clean through. There is a spot right over there that's wore clean through that I'm going to have to figure out what to do with. And then we got this all cleaned up and prepped. You can see there's some gap there, so I'm not going to bevel that too much. Probably just leave it the way it is. Welder seems to be running good on those settings, so let's go ahead. We'll start on this corner. Why not? Start with one of the fun ones. It really is challenging when you've got cow crap down in the weld and you just can't get it all out. So that's one of the challenges with working on trailers, especially livestock trailers. That cow crap and horse crap gets everywhere, and you've got to really clean it out or you're going to fight it. I'm guessing I'm probably going to fight this one, but we'll see how it goes. So let's see what happens. Okay, so I just welded the top piece there, and that went pretty well. I definitely had good penetration because it was sinking down in there pretty good when I stopped. The reason I did the top part first is because now it's going to preheat the material around it, and it may make this more difficult part just a little bit easier, I'm hoping. So I'm trying to clean all the soot out of there. I'm trying to clean that corner the best I can, which I really can't. So I'm just going to have to rely on the process in hopes that it will burn most of that crud out. I'm running this downhill. Oh yeah, she's dirty. I'm going to see if I can gouge this out again. I'll show you what it looks like. It's terrible, but this is what it looks like. So you can see it's not really penetrating like right in here. I want to try to gouge that out and see if I can get it to flow in there a little better. I was able to add this right here, and the top turned out good. So we just need to try to get this a little better. So let me gouge that out with the grinder and let me see if I can get one to flow in there. That's about the best we can do. So I think that's going to work though. First crack's fixed. Let's go over to that opposite corner and see if we can get that welded up. I do just want to say one of the things that I really like about this setup is it's got a 20-foot lead on it. I can walk clear to the end of the table. I've got the welder set up there on the fireball table, and then I'm just able to walk all the way around my table, and I don't have to worry about moving the machine. I've got plenty of room with the lead so that I can get to what I'm working on. That is super nice. All right, so I'm 21.5 volts, 410 on my wire feed speed. This is a thicker material on the inside because it's got reinforcement, so I want a little more heat. I am going to brush that first. You can see right here at first I was getting really good penetration, but it was getting away from me, so I had to stop. I was able to avoid that bolt hole. Just kind of went around it. And then when you get to the edge like this, sometimes it kind of drips on you, so I slowed down, stopped. I'll just clean that up with the grinder. We'll weld the other side, it'll be fine. Okay, so I'm going to roll it over to get that other side. Okay, so one thing to remember with aluminum, especially with aluminum, when you're welding anything, material prep is always important, but especially with aluminum, if you don't get it clean, you will fight it, guaranteed. So the joint on this one was a lot tighter, so I went ahead and gouged that out, and then I hit it with a wire wheel. They say that, you know, like a brush or a wire wheel actually breaks down the oxide layer better and kind of sweeps the surface garbage off instead of like a flat disc that could grind it down deeper into the material. That's just what I was taught. Take it for what it is, make your own opinion, but that's what I was taught. So now that we've got a good joint on this and it's clean, we'll go ahead and weld it out. Remember, when you buy brushes for aluminum, you want to make sure that you buy stainless steel bristled brushes. You don't want mild steel, because that will just impregnate mild steel into the material, which will in turn rust. And they do make both styles, so when you buy them, just be careful that you're buying stainless. Alright, so you can see I started to get a little suck back right there. When I say suck back, it sucks back in. It's a term you hear a lot in pipe welding, because it will get hot and then it will suck back inside the pipe. And I basically got the same thing right here, so what I did is I just ran another little one over the top of that to try to keep it convex. So that one turned out good. Alright, so as far as the cracks go, that's all the repairs that we had to do on the frame. That's not true. I'm going to build that up, so I'll just run bead after bead on that. If it doesn't go the way I want it to with the spool gun, I'll probably have to pull out the Dynasty and just run some beads on that. So I got to build that up, and there is a hole on the bottom. I'm going to look at that, see if I need to repair that. If it's not repairable, then I'm just going to leave it. But we'll go ahead, we'll build this one up, and then this will be done. So once I get that build up, I'll come back and give you a look, and then we'll talk about what's next. All right, so here's one for you. This hole on the bottom, it's wore clear through. It's like paper thin there. I'm gonna try and build this back up. I did the top one already, and then there's another one right here. It's not wore clear through yet. It's close. But I'm going to go ahead and try and build that one up too. There is a lot damaged on this thing. But one thing I will do in this scenario, if I get something and there's just way more work there than I thought there was, or way more work there than they thought there was, I'll give the customer a call and I'll say, look, I've evaluated what I have to do it right. And there's this many hours, and this is my hourly rate. This is about what it's going to cost you. Do you want me to move forward with that, or do you want me to just try and get you back up and running? And I don't really like to do that, but sometimes people just don't have the money to fix it completely the way it should. And so I don't feel like those people should not have the option. So I give those people the option. I can fix it to the point where you're back up and running, but it's not fixed the way I would normally fix it, or we can fix it right, and this is what it's going to cost you. And luckily, this customer said, just go ahead and do it. I want it fixed right. So we're going to go ahead and fix it right. We'll build these back up. We've got to have some surface here because the gate slides on that. And because it was sitting crooked and it was material on material without a wear pad, that's what happens. So we'll go ahead and get these built back up, and then we'll come back and give you a look at all the repair work. There's another one right here. It's not wore clear through yet. It's close, but I'm going to go ahead and try and build that one up too. There is a lot damaged on this thing. Whew. Quick update. I have decided to just cut this out and put a patch in it, weld that out, clean it up. I'll be able to put it in the brake and put kind of a profile on it to try to match this. That's my plan. It'll just take way too long, as thin as this is. I'll bet you I'll start welding on it and it'll burn clear back to here and here. So I'm just going to be better off to just cut it out, put a new piece of material in, weld it out, and buff it off. So I'm going to get that cut out. I'll get the patch made up and tacked into place. I'll give you guys a look so you can see how it looks, and then we'll go from there. That's actually thicker than 10 gauge. Looks like 3/16. So I'm going to go back, find a piece of 3/16. We'll use that. Alright guys, so I went ahead and cut this out, and then I've got a coupon here with some marks on it. I'm going to go ahead and break that to this profile. And then an update on this one, I got this all built back up. So now I'm going to take a flap disc and knock that back down, get it back down to the original surface. I just wanted to show you guys. I started with like the settings for like 14 gauge. I had to keep it cool and slowly build it up. And then I turned it up to 1/8 inch and then up to 3/16. You got to keep it cool when you first start, or you just blow through. So that's where we're at. I'll go ahead and see if I can get this one tacked into place and weld it out. I'll give you guys a look. Alright guys, got our coupon bent just a little bit. It's not perfect, but neither am I, so trying to get this close to flush. At some point you got to move forward. Hurry up! Right there. Okay. Then I'm just going to use a pick here to try to get this close to flush. Oh yeah. Okay. Thank goodness. So I'm going to go ahead and make sure my settings are on 3/16 for this, and then we'll come back and weld it out. Okay, here we go. We're pushing. Alright, we got some beauty work to do. Clean it up with the grinder. We may have to add a couple passes here, get everything smooth and flush. We'll be able to blend this with the grinder. Pretty happy there. Can't ask for too much better than that, considering what it was. And then I'll go ahead, and then I do have to clean this up as well. And I was waiting for this to cool. Usually if I build something up like this, I wait for it to cool, because aluminum gets kind of gummy when it's hot. And if you wait for it to cool, it grinds out better. So you're kind of better off to just wait for it to cool before you get after it. So now that this one's cool, we'll go ahead and clean this one up and get it buffed off. Then we'll step over to this one. This one's still nice and toasty, so we'll let that one cool, and then we'll come back and clean it up when it's ready to grind. All right, guys, we did get these repaired. They are definitely not perfect, but I don't claim to be a bodywork guy, but that's a heck of a lot better than it was, and it's definitely stronger than it was, and it's gonna last a lot longer. So that's repaired now. I think that's pretty much everything, other than I do need to cut those off and weld 2 new ones on. I may wait until the slide gate is done and on so that I'm sure that everything lines up properly. So now the frame's done. Now it's time to tackle this little treat right here. So we'll get it on the table and we'll take a look at what we got to do. We'll hit this one because it's cool. Now that one's nice and hot, so we'll wait for that one. We'll do this one while we're waiting for that one, and you know, we'll finish that one up when we get over. Goodness, I gotta pee, I can't focus.